there's a difference in how devices use electricity. Because atoms have a specific nature to how resistive and conductive and how quantum they really are. Each different type of atom and systems of atoms are different in how they handle electricity or nuclear energy or the E field or the H field, which is an electric field or a magnetic field. Like, for instance, typically we don't make generators or motors unless we have copper wire. So, essentially, you need to learn that because of copper wire's ability to conduct a magnetic field, it makes it special so that it enables the conducting of electricity. So, like, in the instance you're creating, what I really want to hit on here is my videos about my renewable self-energy cycle of a DC to DC motor generator system that I built. Well, the output voltage was 44 volts on one generator, and the input voltage of the driver motor was 12 volts at 0.26 amps. And by the time I got the motor generator hooked up to a battery, I had to use diodes in order to hook it up to the battery so that the battery wouldn't reverse current back into the generator motor, causing it to spin in the same direction that the generator driver was turning. We don't want it to spin itself, so we have to use diodes in a DC-DC motor generator. We had to use diodes on the positive and the negative. The diodes have to be in the forward bias. Okay, so that means that, but the thing is, it's forward bias, but it's forward bias on two like poles. So, I mean, from positive to positive and negative to negative on the generator to the battery, it's in the forward bias from the generator, which means the generator will put current into the battery without the battery pushing current back into the generator, which is forward bias. You can never really, truly, absolutely run a diode in reverse bias. It just doesn't work. You have to have at least one side in forward bias. So it works for like poles. So essentially, when it was all said and done and I measured everything, it was 4 times the amount of voltage that was being produced from the initial voltage. Started as 12 volts, ended up as a little less than 4 times, right at 44, 45 volts. Okay? And I used a gear drive belt that was in a ratio of 1 to 4 to turn the generator. The small gear was on the generator, and the driver had the large gear, which was a 4. So it made the generator turn 4 times faster than the driver motor. So essentially, the current gets to the battery. We test it all out. We hook it up to light bulbs in series, 12 volt light bulbs in series. It lights them all up. The resistance of a light bulb is also different in how it uses current than a battery or a diode or any other device, even a transistor or a capacitor. They're all different in how they use current, even a transformer, anything. They all use current a little bit differently. So by the time it was all said and done, I measured the voltage and I measured the amps, which is called a measurement of volt amps, at just before the diodes of the battery, okay, that were hooked up from the generator. So essentially, I had 44 volts that dropped into 2 batteries, 2 12-volt batteries, and the volt drop turned into anywhere from 25 to 30 volts between two dead batteries. So the voltage was also changing as the batteries began to charge. So essentially, you have a changing condition where charge actually causes things to change, it being an increase in potential energy. So essentially, you start out at the dead position, or it wasn't even really dead. It was just low voltage, very low voltage on the batteries. The generator is just running through two wires to two diodes into a battery. So essentially, you have your resistance of your diodes, and the current was 0.1 amps that was flowing from the generator. It was at maximum 44 all the way down to 25 volts, just above 24 volts for the two 12-volt batteries that were 7 amp hour batteries. They were lead acid batteries. Like, it matters what kind of battery you use as well. All of this matters in how you apply how much volt amps to your system. So you don't want to create an overheating condition. And when you're charging a lead acid battery, the rule of thumb for a 12-volt battery is not to go much more than 2 to 3 volts over the nominal highest charge of the battery. Like in a car battery, typically the voltage is 14.5 volts on an alternator. Because, and this is serious business, because any higher and you will damage the battery. And I've done this to multiple batteries by not understanding that my solar panel was 16 volts. And I was hooking it up to a 12-volt battery. I thought it would be safe enough to run 16 volts into a 12-volt DC battery, and it fried both batteries that was hooked up to this system. What it does is it causes cracks. The higher voltage causes cracks in the lead terminals, and they fracture off and it deadens the battery. So what that means is that batteries are extremely sensitive, especially lead acid batteries. Lead acid batteries are extremely conductive. They are so conductive that it's too easy to charge a battery like that. You only need to use just a couple 2 or 3 volts above their maximum voltage rating. Any higher than that, you will likely damage a lead acid battery, unless it's maybe a deeper cycle battery. Depends on how thick the lead plates are and how much resistance is between the batteries, and how they conduct their electricity in the acidic conditions and the less acidic conditions. So like that can all vary too. So but for the most part, never take a lead acid battery above the voltage of 2 or 3 volts higher than the nominal highest voltage. Okay, that's a 12.6 battery, car battery, never goes beyond 14, 15 volts. And then you apply how many amps it can handle at one time. And it does this through a principle called current adds. Okay, so what you need to know, this is why I'm making this video, is that voltage is voltage. You don't need to worry about what the amps are as much. If the voltage says it's 44 volts, then it's going to run so many amps based on how the device uses current. That's my point. It's that each device uses current differently. So the diodes on the positive terminal was saying 0.1 amps was flowing behind the diode from the generator. But actually, the 44 volts that was reduced by the diode in a what you call a volt divider situation between the diodes and the batteries, it reduced the voltage drop with the diodes, and it was just a basically 1 volt over initially, and then the voltage started to increase as the batteries were quickly charging at higher voltage. So it raised the voltage several bits, and there's a good chance it fried both of the batteries. But it was still charging constantly at 0.1 amps behind the diode. But the battery, the energy that flows around the atoms, which is called an electric field and a magnetic field, which are two different fields. Electric field is actually a nuclear field, or a photonic field in the opposite. So the electric field that flows around atoms and conductors is nuclear. And it actually will flow beyond the resistance of something, and actually the voltage will reintroduce itself into, like, say, a battery in this case. It will become the voltage that it is beyond the resistive factor of the diode. So whatever that is on the opposite side is what the voltage really is, and that's how many amps can flow based on the resistance of the battery into the battery. And batteries have very low resistance, extremely low, especially lead acid batteries and lithium ion batteries too. Any battery I've ever seen that's on the market commonly today is very low resistance batteries, and they charge really easy. So, like, basically that may have been 0.1 amps flowing before the diode, which would have said that my system wasn't conducting as much current as it was using. It was putting out half the amount of current that it was using at 0.26 amps that it was using. So 1 to 0.26, that's a lot. That's a little less than half. That's a significant amount less than half. So what you need to know is it's really not less than half. It will step up itself a lot in the function of the battery. Batteries have the ability to even chain react. When you put energy into a voltage into a battery, it causes a chain reaction that will charge multiple molecular structures in a battery at a time. It doesn't charge just each molecule. It charges multiples in chain reaction. So that's what you also need to know about batteries, is that's another reason why they're so easy to charge, is because they charge multiples in chain reaction of molecules. And basically, the amperage that was on before that diode is definitely going to be a lot more voltage in the battery than it was the diode. The diode is a lot more resistive. So the voltage is going to outperform in the battery than it did in the diode, especially for multiple reasons. Especially because the conductivity of the lead and the battery and the electrolyte, and not only that, it chain reacts when you charge it, and it undergoes what we call current adds, which are like circuit adds, and then it basically constantly charges the battery until it gets charged. I showed a video that I already produced on all of this, and I actually showed the evidence of it, and it's true. It's going to charge that battery really fast because it was high voltage, and the amp didn't roll. The amp rating, the volt amp rating, before the diode doesn't necessarily tell you absolutely how much energy you're putting into that battery, because it's actually more in the battery than it is in the diode. So you have to make multiple measuring points. And you have to understand quantum physics in order to understand that things chain react and they create multiples. Actually, what you need to know is that life is much more efficient than we actually thought. It has a way to use energy much more easily than we really know. Like a low temperature in biology, like to me and you, 90 degrees temperature Fahrenheit doesn't really mean much to us. But actually, it's enough energy to conduct organic chemistry. It causes the organic molecules in your body to react and even ionize. We've proven this. We know this for sure. Just do a PCR experiment, polymerase chain reaction. It only takes a few 60 to 90 degrees to get a polymer chain reaction to polymerase chain reaction going, and it modifies the DNA components of polymerase chain reaction. It's really not that complicated to understand. Even low temperatures can concentrate into higher temperatures. There's much more efficiency than physics books will actually tell you. It produces more energy than you thought it did, and you may not feel it, but it produces energy. But so that's what I wanted to say about this motor generator that I created. And this is the end of the video, so it's a very long video. 16 minutes, almost 17 minutes. I'm going to stop at 17. Peace.